As Tazagi is said to have noted, there is no glory in foundations. Indeed, most of our work is buried. For example, everyone knows the Eiffel Tower in Paris, but very few know about its foundation. The foundation was built by excavating down to the water level about 7 meters deep, but the soil at that depth was not strong enough to support the 100 meganewton weight of the tower, so digging continued. Because of the water coming from the River Seine, the deepening of the excavation had to be done using pressurized caissons, upside-down coffee cans, so that the air pressure could balance the water pressure and keep it out of the excavation. Workers got into these 14 times 6 times 15 meters caissons and worked literally under pressure until they reached a depth where the soil was strong enough to support the tower, about 13 meters on the side closest to the river and about 8 meters on the side away from the river. Among some notable geotechnical engineering projects and developments are the underpinning of the foundation of the Washington Monument in 1878. The foundation blocks were set in a mixture of lime mortar and cement to form a stepped-up truncated pyramid 7.4 meters square at the base. The foundation extended 2.3 meter below ground and 4.8 meter above. However, it proved to be incapable of supporting the projected height and weight of the monument and was later modified when the project was completed by the Army engineers. The Panama Canal, 1913, and its slope stability problems. In August 15, 1914, the canal opened to shipping. Shortly afterward, the two largest landslides, called the East and West Culebra landslides, 13 and 10 million cubic meter in motion, respectively, slipped simultaneously. These landslides closed the canal for much of its second year of operation, while dredges worked to reopen the channel. Although landslides have not blocked the canal since 1920, they still threaten navigation. They have partially obstructed it in 3 instances. Debris from the East Culebra Extension landslide, 2.4 million cubic meter in motion, restricted navigation in 1931 and 1974. The East Cucaracha landslide, 4.6 million cubic meter in motion, nearly closed the canal in 1986. The Tower of Pisa, 1310, and its foundation repair in 1990. The monument began to lean in 1178 when the construction works were barely started. During the course of 800 years, the lean constantly increased, so much to become a cause of concern by the end of the previous century. The solution to this problem was then to reinforce the soil under the foundation and to make room for the tower to compress some of the soil and straighten back up towards the north. The tower leans to south. They did this in the frame of a project launched in 1990. The project total cost was over 30 million euros, and it lasted 10 years. The locks and dams on the Mississippi River in 1990 and their gigantic deep foundations. Construction began in 1979, the main lock opened in 1990, and the full structure was completed in 1994. It replaced the earlier lock and dam number 26, demolished in 1990, and is the first replacement structure on the Upper Mississippi River 9-foot navigation project. The main lock is 370 meters long and 34 meters wide. The auxiliary is 180 meters long and 34 meters wide. The main lock has a vertical lift gate and a miter gate, while the O-lock has 2 miter gates. The dam is 350 meters long, with 9 tainter gates, each 34 meters wide by 13 meters high. Tokyo Haneda Airport runway extension in 2010. In August 2010, the 4th runway, called D runway, 2,500 meter long, was completed off the shore of the Tokyo International Airport, Haneda Airport. Since the D runway is situated at the mouth of the Tamagawa River, a hybrid structure combining a piled elevated platform and land reclamation was planned, so that it would not obstruct the flow of the river. In the reclamation area, a slope-type rubble mound seawall was constructed on the soft clay seabed, which was improved using the sand compaction pile method, with a total of 52 million cubic meters of soil, sand and rock used in the land reclamation. The piled elevated platform is a massive 520,000 square meters structure in which 198 prefabricated steel jackets supported by 1,165 steel pipe piles were connected together by welding on site. This project required huge quantities of construction materials, including 470,000 tons of steel and 450,000 cubic meters of concrete. The D runway was successfully constructed in just 3.5 years, thanks to the rapid construction method and a continuous 24 hours a day work schedule.